We are looking at page 61 in your portfolio. So please turn to page 61. We are going to modify the given equation. Instead of what we had given, we're going to have y equals 4 to the x minus 9. Again, this is page 61. You can cross that off here. We're going to be evaluating the expression 4 to the x minus 9 with the given x values here in the left part of our table. So we haven't studied what happens when we have a negative exponent. And so we're just all going to put this into our calculator and evaluate it in that way, because it's more, we want to take a more holistic look at just what the graph of this looks like. And we're going to need to show some negative values for x in order to get a more complete picture. So I'm going to take my expression, my given expression of 4 to the x. Well, for this first row, my x is negative 2. So that's 4 to the negative 2 minus 9. So I'm going to go to my calculator and I'm going to do 4, and my exponent is going to be this little, I called that a caret key. It looked like a little up arrow to show me that is negative 2. Is an exponent, and then I'm going to type in my negative 2 next to that. So you can see that in the picture there. And you see that we get 625 10,000ths. So a tiny value. It's actually 1/16. And so I'm going to write that here. 0.0625 minus 9. And on your calculator, you still have that value stored there. So you don't want to clear that out and retype that. You just want to hit subtract 9. And so it's going to take 9 from that previous answer. And so we're subtracting a much bigger number, which is going to make our answer negative. And so we have negative 8.9375. And I'm going to plot these values all at once at the end, but I'm going to record them here in my table. So when x is negative 2, y is approximately negative 8.9. And I'm just going to round it like that for that small space that I have there. So almost negative 9. I'm going to substitute in negative 1 in my next spot. So 4 raised to the negative 1 power minus 9. And again, I'm going to put that into my calculator. So 4 raised to the negative 1 power is 0.25. That's a quarter. And we're going to subtract 9. So we're subtracting this much bigger number. So I'm going to get a negative answer again. And so I'm getting negative 8.75. So my ordered pair is negative 1 for x. Then my y would be negative 8.75. I'm going to put that right there. I'm going to plug in 0. 4 to the 0 power minus 9. Some of you might recognize that exponent, but many of you probably do not. 4 raised to the 0 power equals 1. So 1 minus 9. Again, we can do this on our calculator, but you can also think of this on a number line. So that gives us negative 8 to kind of think about where that is on a number line. We can even use our grid here, right? If I am at positive 1 and I'm taking away 9, and I go 9 to the left, I'm going to end up here at negative 8. So you can use that information. You can use the number line that's right in your given coordinate plane. So my ordered pair, when x is 0, y is equal to negative 8. So that's the ordered pair that corresponds there. You can pause here and do these remaining 2 on your own, and then come back and check your answer. For those of you that want to watch the step-by-step, you can view now. If you don't want to, you can skip ahead to just check your answer. 4 to the first power, again, you can type that in, or you can know 4 multiplied just one time is just 4. And if I'm subtracting 9, that's going to give me -5. And again, if I want to think about this on my number line, I can think of being at 4 and subtracting 9. That would be going in the left direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. That puts me at -5, which is exactly what I got. So use those resources. If you don't have a number line in front of you, but you do have a coordinate plane, you actually do have a number line to look at. So my ordered pair here, when x is 1, my y is -5. And finally, if I have 4 squared, that's 4 times 4, or 16, minus 9 is going to give me 7. And so if x is 2, my y value is 7. So let's plot these points and see what's going on with our graph. Let's scoot this up a little bit. So I'm going to plot my easier numbers first. I'm not going to plot these decimals until the end. So let's start at the bottom of my table, since that looks nice and doable. When x is 2, and remember this is my x-axis, the horizontal axis, and my vertical axis is y. If I start to the right 2 and up 7, I will have a point right there. At 1, -5, I am way down here. Wow, that's a big jump. At 0, so I don't go left or right at all, and I'm at -8. My y is -8. That's way down here. And at -1, I'm at 8.75. So 3/4 of the way to 9. And then at -2, so 1 further over, I'm just closer to 9. And that's a characteristic that we'll study more. But an exponential graph, remember, it has a slow increase or decrease at first and then very quick. So this graph is going to be really flat like this. And then it's going to go steeper and steeper. So you can't use a straight edge on this. The only thing you're going to use a straight edge for is your lines. If you wanted to see just how quick it's going to go up, we could plug in 3 here and kind of see what happens. I think it's going to be off of our graph, but it would be interesting to see. So 4 to the 3rd power minus 9. 4 to the 3rd power is 64. So 64 minus 9 is 55. If I put that there, just to kind of get a feel for, now you're going up all the way to 55 in our table. So that just shows that exponential going up faster and faster. So just one spot over here is way up off my graph at 55. So some of the key characteristics of this exponential function, hopefully you recognize that as an exponential function, is that it's always increasing or always decreasing. In this case, it's an increasing graph, and it starts off slow and then it goes quicker and quicker.